Hi, Mr. Richards here. Today's lesson is on trigonometric ratios. Our first definition is that of trigonometry, and it is the study of relationships among the angles and sides of triangles. And when we deal with trigonometric ratios, this compares the side lengths of two sides of a right triangle. And in our key concept box of trigonometric ratios, we see our words sine of angle A, cosine of angle A, and tangent of angle A. There is a way of learning this called SOHCAHTOA, where SOHCAHTOA, where we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if we look at these relationships, the sine of angle A is opposite over hypotenuse. So the opposite side of A is this A, and the hypotenuse in this triangle is opposite the right angle, so C, so A over C. The cosine of angle A is adjacent over hypotenuse. The side adjacent to A is B. The hypotenuse is still C. And tangent of angle A is opposite over adjacent. The opposite of A is again A here, and the adjacent is B. So we're going to be using SOHCAHTOA to help us find angles and sides of right triangles. Find the values of the three trigonometric ratios for angle B. Well, let's highlight what angle B is, and that's this angle up here. That's our B. And so the first thing that I do is I label what is my opposite side. Well, the opposite side to B is the 12. So that's the opposite. Well, the right angle tells us where the hypotenuse is. And opposite the right angle is the hypotenuse. So this 13 is my hypotenuse. Which leaves us then with our adjacent, and that is here at B. Is my adjacent side. And so to find the values of the three trigonometric ratios for angle B, we can start off with our SOHCAHTOA. And our first step is actually going to be to find what is the length of side B. We need to know that length. And so what we're going to do is use the Pythagorean theorem to find B. So we will use a squared plus b squared equals c squared. So 12 squared plus b squared equals 13 squared. 144 plus b squared equals 169. Subtract the 144 from both sides. B squared equals 25. And if we take the square root of both sides, b is going to equal 5. So my adjacent side is 5. Next, we're going to use side lengths to write trigonometric ratios. So the sine of B is the opposite over the hypotenuse. And so sine of B is going to be the opposite side, which is 12, over the hypotenuse side, which is 13. So 12 over 13. Then, what about cosine? Well, the cosine is equal to the adjacent over the hypotenuse. And so for the cosine of B, this is going to be the adjacent, which is 5, over the hypotenuse, which was 13. And lastly, we have our tangent. So the tangent of B is equal to the opposite over adjacent. And our opposite is 12 over the adjacent, which was 5. The tangent of angle B is 12 over 5. And those are our solutions. And if we try to solve this one more time, we're again looking to find the values of the 3 trigonometric ratios for angle B. So first we're going to identify, here's angle B, and then the side opposite to that here is B. The other side is the adjacent side, and the one across from the right angle is the hypotenuse. So once again, my first step here is going to be finding my missing side, which in this case is B. And we'll use the Pythagorean theorem, a squared plus b squared equals c squared. So we'll take our two legs, which are 8 squared plus b squared equals the hypotenuse, which is 17 squared. 64 plus b squared equals 289. Subtract that 64 from both sides, and b squared is going to equal 225. Once we take the square root of both sides, b is going to equal 15. So that opposite side then is 15. Now, to write the trigonometric ratios, we start off with our SO, CA, TOA. The sine of B is equal to the opposite over hypotenuse, which is, the opposite is 15 over the hypotenuse, 17. Cosine of B is the adjacent over the hypotenuse. The adjacent side is 8. The hypotenuse is 17. And lastly, we have tangent of B. That's opposite over adjacent. The opposite side is 15, and the adjacent is 8. So those are the values of the 3 trigonometric ratios for angle B. In our next examples, use a calculator to find the tangent of 52 degrees to the nearest 10,000th. And before we start this, we need to ensure that our calculator has the right settings. So ensure your calculator is in degrees, and the opposite of that is radians, so we do not want this in radians for these calculations today. Not radians. Well, if you punch in tangent of 52 degrees, you'll have a decimal that comes out as 1.27994, and it keeps going. Now remember, where is your 10,000ths place? You have tens, hundreds, thousands, 10,000ths. So to round to the nearest 10,000ths, you need the 10,000ths and the 100,000ths. And so as we look at this 9 in the 10,000th spot and look over to the 4, that 4 is not going to round the 9 up. So it's 1 and 2,799 10,000ths. If you were to type in the sine of 84 degrees into your calculator, as long as it's set in degrees, you have 0.99452. And again, you want to write these out to the 100,000ths spot, so you can look at the 10,000ths, look over to the 100,000ths, and see if it's going to round. In this case, our final answer is 9,945 10,000ths. And now comes the heart of these examples today. Solve the entire right triangle, round each side to the nearest tenth. Well, our first step, step 1, is to find the missing angle measure. It's going to be the first thing that we want to do, find the missing angle measure. Well, we know that in a triangle, angle A plus B plus C add up to 180 degrees. So far I know 62 and 90, and I'm looking for angle A, needs to equal 180 degrees. So once I add 62 and 90 to get 152, I know that 152 plus A equals 180. Subtract the 152 from both sides, and I know the measure of angle A is then 28 degrees. That's the first part of this. That is 28 degrees. Next, in step 2, let's go to try to find one of these missing sides, either A or C, and we might as well do this in alphabetical order. So we'll find A. Now, if we look at our SOHCAHTOA, pick one of the angles that's not the right angle to use here. You could pick the 28 or you could pick the 62. I'm going to pick the 28 degrees here to use. That's going to be my go-to angle here. And so when I look to label this triangle, then using that 28 degrees, the hypotenuse is the C. It's opposite the right angle. The side opposite the 28 is A. So I'm going to label that as my opposite. And that leaves my other side, the 14, as my adjacent side. So now what? We have SOHCAHTOA. We have our triangle labeled adjacent, opposite, hypotenuse. We need to use one of these three in order to find A. Well, what is A? A is the opposite side. What else do I know? I know the adjacent side. So I need to use a relationship that involves the opposite side and the adjacent side. The opposite side and the adjacent side. Well, that's going to get me to the tangent relationship. So the tangent of angle A is equal to the opposite side over the adjacent side. And so if I make my substitutions in here, the tangent of 28 degrees is going to equal that opposite side, which is A, over the adjacent side, which was 14. Now, before I punch in the tangent of 28 degrees into a calculator, let's get our variable alone. Let's solve for that variable. So if I multiply by 14 on both sides here, this ends up canceling, this 14 and 14 here, and I'm left with 14 times the tangent of 28 degrees is going to equal side A. And if you type in 14 times tangent 28 degrees, you will end up with 7 4/10 for A. And that's the length of A. Our last step, step 3, we have one more missing side to find. We need to find C. And if I start off with my relationships again, so, ka, to, a. If I'm looking to find C, C is the hypotenuse. And we are given the adjacent, so let's stick with the adjacent and the hypotenuse here. Well, which of these relationships deals with adjacents and hypotenuse? That's going to be cosine. Cosine deals with adjacents and hypotenuses. So then the cosine of angle A, which is 28 degrees, is going to equal the adjacent side, which is 14, over the hypotenuse, which is C. Now, I do need to solve to get the C alone. And so what I'm going to do here first is actually, it's going to be a little weird, I'm going to multiply by C on both sides. And you'll see why I'm doing this in a moment, no pun intended there. C times the cosine of 28 degrees is going to equal 14 because this canceled out. And now if I divide by the cosine of 28 degrees on both sides, what we're left with here is this canceling and getting C equals 14 divided by the cosine of 28 degrees. And if you type in 14 divided by the cosine of 28 degrees in a calculator, you would end up with C equals 15.86. And if we're rounding this to the nearest tenth, as our directions asks us to do, you would have 15 9/10 for C. So step 1, find your missing angle measure. And then your second and third steps are to use your trigonometric ratios in order to find the missing lengths. What about this right triangle? Solve the right triangle, round each side to the nearest tenth. We'll go through this one a little bit quicker now. Our first step, step 1, is to find the missing angle. So that's the measure of angle A. Again, we know the 90 and the 36 plus A has to equal 180. And once you add and subtract, you'll get the measure of angle A equals 54 degrees. And that's the first part of our solution as we look to solve the right triangle. Solving the right triangle means find all the missing angles, all the missing sides. Now, step 2. Let's pick a side to find. Let's find A. Now, as we look at our angles, we're given the 36. Let's just use that this time. Let's use angle B as our starter here. So as I look at so, ka, toa, and if I label this triangle, the opposite of angle B is this side over here, the 6. The hypotenuse is the C, which leaves us the adjacent at A. So again, the opposite to B was 6. The hypotenuse is opposite the right angle is C, and the adjacent side is A. So if I'm looking for A is the adjacent to B, and I'm given the opposite. So I need a relationship with the adjacent and the opposite, which again is tangent. So this is going to be solved as the tangent now of 36 degrees is going to equal that opposite side, which is 6, over the adjacent side, which is A. And now if I multiply by A on both sides, this cancels out. We're left with A times the tangent of 36 degrees equals 6. Then we divide by the tangent of 36 degrees on both sides. And again, our goal is to get everything on one side so we have our variable alone. So A is going to equal 6 divided by the tangent of 36 degrees. Take 6 divided by the tangent of 36, and A is going to equal 8 26/100ths. And rounding to the nearest tenth, A equals 8 3/10. We have one more missing side here, and so we need to find C. And I'll once again write my so, ka, toa, and if you haven't memorized it yet, you will soon. And so if I'm using angle B, once again, I'm looking for the hypotenuse, and I'm given the opposite. So if we're looking for opposite and hypotenuse, well, opposite and hypotenuse takes us to sine. So I'm going to say that the sine of 36 degrees is equal to the opposite side, which is 6, over the hypotenuse, which is C. And now, to get the variable alone, we'll start by multiplying by C on both sides. So that cancels. And we're left with C times the sine of 36 degrees equals 6. And if we now divide by the sine of 36 degrees on both sides, this cancels. And C is going to equal 6 divided by the sine of 36 degrees, and 6 divided by the sine of 36 is going to end up with 10 21/100ths, and rounded to the nearest tenth, C is 10 2/10. So step 1, find the missing angle. Step 2 and 3, use your trigonometric ratios to find your missing sides. So now we have a real-world link. A conveyor belt moves recycled materials from station A to B. The angle the conveyor belt makes with the floor of the first station is 15 degrees. The conveyor belt is 18 feet long. What is the approximate height of the floor of station B relative to station A? All right, so we are given angle A here. We're given angle A is 15 degrees. And so the side opposite of that is H, and the hypotenuse, the side across from the right angle, is the 18. And so as I look for so, ka, toa, which relationship am I honing in on? Well, I need the opposite and the hypotenuse, which is sine. So the sine of 15 degrees is equal to the opposite side, which is H, over the hypotenuse, which is 18. If I multiply by 18 on both sides, I end up with 18 times the sine of 15 degrees equals H. And 18 times the sine of 15 degrees is 4 66/100ths. Round to the nearest tenth is 4 7/10 feet. A bicycle ramp is 5 feet long. The angle the ramp makes with the ground is 24 degrees. What is the approximate height of the ramp? Very similar problem here to one we just solved. There's our 24 degrees. The side opposite to that angle is the H, so we'll label that our opposite. Across from the right angle, we find our hypotenuse. Not that we need it, but this other side would be our adjacent. And so as we look at our so, ka, toa once again, which relationship are we going to use? We need our opposite and hypotenuse again, which is, once again, sine. So the sine of 24 degrees is equal to the opposite side, which is h, over the hypotenuse, which is 5. If we multiply by 5 on both sides, we get this to cancel out, so that 5 times the sine of 24 degrees is equal to h. And this is simply 2 3/100, so when you multiply, and round to the nearest tenth is 2.0 feet. In our textbook, it reads on page 658, a trigonometric function has a rule given by a trigonometric ratio. If you know the sine, cosine, or tangent of an acute angle, you can use the inverse of the trigonometric function to find the measure of the angle. So we're going to be using inverse trigonometric functions here. Now, one thing to note before we get started here with this notation is something like the cosine negative 1x, which is the inverse cosine. This does not equal like negative exponents 1 over the cosine of x, or sine, or tangent, just to make sure that we have that clear. Now, if angle A is an acute angle and the sine of A is x, then the inverse sine of x is the measure of angle A. Same thing for cosine, same thing for tangent. Now let's go ahead and go through a couple of examples because that might make this make just a little bit more sense. Find the measure of angle P to the nearest degree. So we're here looking for angle P. Well, if we look towards the opposite side here, here's our opposite. The 24 would be our hypotenuse, and the 22 is our adjacent side. So as we look at SO, CA, TOA, we are here looking then, what are we given? The adjacent and the hypotenuse. Well, that is our cosine. So one thing we can now say is that, all right, the cosine of angle P is equal to the adjacent side, which is 22, over the hypotenuse, which is 24. Now, one thing we could do with the inverse cosine now to find the actual angle, say, okay, my inverse cosine is going to be the 22 over 24, and that's going to equal the measure of angle P. And so in a calculator, if you type in inverse cosine 22 over 24, you will come up with 24 degrees equals the measure of angle P. In our last example of this lesson, finding the measure of angle L, looking, here's the opposite side, hypotenuse, and adjacent now. So we're given in our SO, CA, TOA, we're given the adjacent and the hypotenuse, which was once again cosine. So the cosine of angle L is equal to the adjacent, which is 23, over the hypotenuse, which is 30. So then the inverse cosine of 23 over 30 is going to equal the measure of angle L. And in a calculator, that is 39.94 degrees equals the measure of angle L. And rounded to the nearest degree, that is 40 degrees equals the measure of angle L. And that is it for this lesson on trigonometric ratios. Good luck.